Hello, my name is Tyler with Contrast Security. Today we're going to be talking about runtime application security. We're going to work through what that means and how it compares to other technologies you may be using to defend your applications. At its core, runtime security means embedding lightweight sensors into applications during production. These sensors have the ability to monitor every execution path, every data flow, every function call in real time. We use this visibility to identify vulnerable conditions and, most importantly, detect when those conditions are being exploited. Unlike perimeter tools, runtime doesn't rely entirely on outside traffic patterns to catch exploits. And unlike static tools, there's no guesswork of what the code's going to do. We simply watch the code as it's executing and make our determinations off that. This is why we can achieve much higher accuracy when it comes to identifying vulnerabilities and then correlating those detections to exploitation. It's something EDRs and WAFs simply can't do when it comes to application security. Next, we're going to show the 2 steps of runtime protection, how the sensors are placed inside of your application, and then how they analyze and respond in real time. Step 1 is instrumentation. Once installed, agents automatically inject sensors into Java, .NET, Node.js, Python, and other runtimes. These sensors track security-relevant methods, data movement, and API interactions. Next comes analysis and response. AVM detects vulnerable conditions by performing data flow analysis, tracking untrusted inputs to sensitive sinks. ADR will detect when the vulnerabilities are being exploited. In that scenario, Contrast can make the real-time response to block the attack without disrupting legitimate users. We put together a cheat sheet to help compare runtime to traditional tools, so you can see exactly what each tech does and where they might struggle. In short, while inside of an operating system, EDRs can't see inside of an application. Therefore, they can't provide enough signal about what's happening there. Meanwhile, WAFs are outside of the application, and they can't tell the difference between an effective and ineffective exploit, leaving you in a sea of signals not knowing what's real and what's not. Runtime security detects vulnerabilities and attacks that can get lost in the sea of static findings or missed in the overwhelming volume of perimeter alerts. SQL injection, deserialization, path traversal, command injection, and beyond can all be detected at the moment of exploitation inside of the app where they're most easily seen, not hours or weeks later buried in some backlog. When it comes to understanding an application's construction, Contrast can help here too. We're building a digital twin of your application so you can see all the services, authentication, databases, file reads, and libraries running inside of your app. This helps with threat models, incident response, pen tests, code reviews, and beyond. All of that can be done far more effectively. Speaking of libraries, Contrast can help you identify dependencies with CVEs, but most importantly, we can tell you when that library is in use or not. This helps you prioritize the things that matter most, the things that are at risk and exposed and potentially vulnerable. For security teams, the operational impact is huge. With runtime and ADR, false positives disappear. SOCs get runtime, verified alerts, and mean time to remediate drops from months to hours. Developers win here too. Contrast provides attack payloads, requests, and stack traces to pinpoint exactly where the problem is. So that's it for the breakdown of application runtime security. Hopefully you got a taste of what it's all about and how it can help you close the gap on existing defenses. Thanks for watching.